Hello and welcome. This is the second module of the Facilitators Programme in the Code with Altino series. It's called Artificial Intelligence and Coding, Why and How to Teach It. Let's get straight onto it. The learning outcomes for this module. Firstly, to understand the importance of computer coding for your students' futures. Secondly, to understand the meaning of computer coding or programming. Thirdly, to understand how you can teach computer coding in your school, even if you've never had any computer programming experience. So let's start looking at the importance of computer coding. In 2018, the World Economic Forum asked Australian companies what will be the top 10 jobs in Australia in 2022. Well, here at Scion Australia, we have put together an educational video on this survey, and we're about to click onto the internet to look at this video. There are lots of links like this in the Code with Altino curriculum, so this is just an example to show you need to be connected to the internet. So here we go. Here is the link. I'm going to click on the video and then put it onto full screen. Of me, so we'll click out of that. So we finish the video and we click the minimizing window for the internet and it goes straight back to our presentation. And as it showed on the video, the number one job mentioned by Australian businesses is for software and applications developers and analysts. The world is changing. So why is computer coding important for today's students? Your students of today will witness human life on Mars in their lifetime. They may travel to outer space. They do not know what it was like with no internet or smartphones. Many of their future careers will use some form of software programming and/or managing data. Now that is just what we've seen in the previous video. They describe themselves as being part of the Netflix generation. What does that mean? It means their expectations mean instant availability of entertainment content and instant availability of any content via the internet. Now that content also means educational. So we are obviously dealing with different generational expectations now. So how does coding and robots fit into this? Firstly, coding builds software. Software is used to control robots. Robots provide us with a physical link between what we are thinking and what is happening in the real world. Or in other words, solving problems in the real world. And there we have an example of a robot mailman. So for example, just today I read about a robot that was being built for dairy farms in Australia. This robot goes into tanks that are very dirty and quite dangerous, stainless steel tanks for farmers to go into. So instead they can send robots in that have magnets. And these magnetic robots have been developed at universities. But now this company has come up with a way to apply that technology. So what we are talking about is a robotics revolution happening all over the world, happening globally. You will see more articles about this every day, just as I talked just today about the robot in dairy farms placed in tanks. So where is Australia placed in this global robotics revolution? As you can see from the slide, we are in moderate growth with robotics. The aggressive economies are in Indonesia, South Korea, Taiwan and Thailand. So we at Scion Australia are privileged to work with Scion Co in South Korea, who are leaders in educational robotics in the world, as we've just seen in the previous slide. Scion have provided us and our school customers with a great article that specifies the future of AI or artificial intelligence and robotics and its impact on human society. We have transposed the content for Australian audience. This link is not publicly available. So I'm going to click on the link now. You can read it at your leisure. And here is the English translation. So there is the article and it's ready for you to read at your leisure as mentioned. One of the main points of the article is which jobs of the future are under threat, for want of a better term, from the AI revolution with the goal of increasing productivity. As a profession involving helping and caring for people, teaching is not on the target list. Reading the article will help you understand the context. So from page 6, on the other hand, artificial intelligence will not be able to replace jobs that focus on helping and caring for people, persuading and negotiating others, jobs that have strong artistic and emotional characteristics, or jobs that require a combination of ideas or a comprehensive and creative way of thinking in a novel way that is different from conventional methods. So what is artificial intelligence? How do you know if a device possesses artificial intelligence or AI? So the definition is, a useful definition in an educational context like this, is any device that perceives its environment and takes actions that maximise its chance of successfully achieving its goals. So for example, the robot that we were talking about to go into tanks, that is perceiving its environment with sensors, and then the idea of that is to clean up, find the mess and to clean up in non-technical terms, and to clean up that mess. So that would be defined as an artificially intelligent robot. But as we can see by the Venn diagram below, you have robots that are not artificially intelligent, and you also have artificial intelligence that are not robots. Altino, the robot car, is an artificially intelligent robot. It perceives its environment and takes actions that maximise its chances of successfully achieving its goals, and that's what makes this product really exciting and fantastic for educational purposes. So why coding and robots? So as we've already seen, by learning how to create software using AI robotics, We are empowering our students to solve problems and translate them to the physical world. So this is a really important, one of the most important takeaways I would like you to take away from this facilitators program. By learning how to create software using AI robotics, we are empowering our students to solve problems and translate them to the physical world. And that's what makes this curriculum exciting, because it is about STEM and problem solving. So the Australian education system has responded to this and recognises the importance of teaching coding today in our schools. The formula below is published in NESA's, this is a New South Wales syllabus website, for example. So CS being computer science plus the student's area of interest or passion. It's almost becoming like reading, writing and arithmetic, where it underlies all other subjects and will underlie all the students' futures. So even if we as teachers do not have interest in the technology, and even if the student, for example, doesn't have interest in computer science or technology, we do have a responsibility to show them the importance of technology and how they can bring it into their careers and how they can bring technology into their lives. And I hope that by the end of this facilitators program, you can see how you can achieve that. So our responsibility as school educators is to transfer our students from users of technology. For example, just using video games in that context, the student is just a user. Somebody else has developed the software for that game, but they are the end users. We want our students to be creators of technology. So here's an example of what one of our Code with Altino Year 6 students did, talked about, and she's also used Google Schools to show this presentation and what she achieved on using Altino the robot car. She's now a creator of technology. She's programmed the robot and she's using presentation methods to show that. So what is coding? Coding is a list of step-by-step instructions that get computers to do what you want them to do. As you know, it's also called computer programming. Or in another way, you may not like to describe it as giving a directive to a computer. So there is an example of a computer programming block from the Scratch language, where you're actually telling the computer to turn their forward light on or turn their brake light on, for example. So in an education context, coding shows students how to solve problems in the real world, not just from a textbook or not just from coding to move animated characters up and down. It teaches algorithmic thinking in a STEM and STEAM context, and your students have the opportunity to work with real-world data, and that's really exciting, and we'll show you how that works later in the facilitators program. What is the best way to teach coding? The Code with Altino curriculum teaches coding in a step-by-step fashion and builds the student's confidence with every task. Learning the Scratch language with Altino the robot car is ideal for primary students, as it is a simple, visual and tactile way to get started. That is, it provides a great foundation for learning how to code or program a computer. And NESA in New South Wales, they really push visual and tactile learning as part of their syllabus, as it's much more powerful. There are 3 essential factors for a student to get a good grasp of coding. Firstly, syntax. That simply means the language of the code. What does it look like? Just as the syntax of English looks different to the syntax of, say, Chinese or French. Secondly, semantics. What the language means and its purpose. Thirdly, its application. How the code can be applied to real-life tasks. So again, we set up an educational video to best explain this. And here it is, this video too. And again, I'll go full screen once the video comes up. So again, I press the minimisation on the internet and that takes me straight back to the presentation. So what that video showed is once a student understands the three factors, syntax, semantics, application, and are fully competent in the Scratch language, they are ready to move on to a more advanced language, and that could be, for example, Python or C, as they already have a strong foundation in the semantics and the application. As they learn more advanced languages, they only need to learn the syntax, that is the language of the code. This slide is relevant to New South Wales Education Standards. The previous video discusses how to use Scratch as a strong foundation language for learning how to code. Scratch is a visual or block-based language. However, programs such as Python and C language are text-based. They can also be called a general-purpose programming language. In the New South Wales Education Standards for Years 7 and 8, or NESA Stage 4, part of the technology mandatory syllabus includes designs algorithms for digital solutions and implements them in a general-purpose programming language. The Teacher's Guide to the Code with Altino curriculum, which is included in a later module of this Facilitators Program, takes this into account, separating early high school students into those who are coding beginners and those who are not to determine the best learning pathway for each group. So just to summarise our role as educators, to teach students to be technology masters, not just users, and we do that by showing them how to program software. Our role is to inspire confidence in new technologies, computer coding and STEM. So even though you may not be confident, and even though you're not really the sort of person who is happy with technology, you really need to think more about what you will gain from change and new technologies rather than what you may lose. Similar to, say, when you're going through a software upgrade on your computer, sometimes it's frustrating because you might lose a couple of functions, but at the same time the software has been upgraded for a reason and there could well be very many benefits for you. So that's the sort of the way that you need to focus on when you're teaching technology. You need to show confidence for the students. Not confidence in your own skills, but confidence in the importance of the students learning about technology. And not simply deliver content. You need to use your teaching skills, for example, your great coaching and facilitation skills to encourage teamwork, problem solving, learning from mistakes and persistence. You'll hear a lot in education circles now about the word collaboration, and that's what that means. To teach analytical and critical thinking to manage content, and of course to teach social skills and ethics, which, as I'm sure you realise, becoming more important in the future. So here is a fascinating fact. Did you know that popular search engines such as Google have built-in algorithms that develop a filter bubble? This means that users, i.e. all of us who search for information on Google, are more likely to see information that supports our current way of thinking. This is building a strange spiral of thinking. As teachers, we can coach our students to think critically about information available to your students at a keystroke. So just a bit of a stimulus question, we won't go through it here, but consider this information with, for example, the increasing popularity of parents electing not to immunise their children. So teaching students to code or program a computer is a journey to a worthwhile destination. I hope that you believe that after watching this module. Your abilities, however, in teaching and coaching are more important than your technical skills. This curriculum has been designed with non-coding teachers in mind, teachers who had never coded a computer before. We will show you how this will be achieved in a later module in the Facilitators Program. So we can use the iceberg analogy here to show that in a picture. So you're probably familiar with this, but the iceberg analogy is only 10% of the iceberg is above the water, and that's what people see. And for instance, they may see success. What people don't see is the journey to that success, 90% of the iceberg that's underwater, where people have persisted, they've failed, they've sacrificed, gone through disappointment, etc. As teachers, through the STEM process, through the problem solving that your students will go through with the activities with Altino, you may see some of this from the students, particularly that are ones that don't pick up things so quickly. So where you come in is to encourage the problem solving, to encourage the failure, and to mention, yes, failure is your pathway to see how this works, but you will not succeed until you try. Problem solve, try again. Problem solve, try again. That is all part of the STEM learning. And that's where great teachers come in to help the students through that process. So that's the end of that module. Thank you.